Welcome back to the deep dive. This is where we break down complex ideas into, well, crystal clear insights you can actually use. And if you're a smart, thoughtful person, I'm thinking of the coaches, the practitioners, maybe you're an entrepreneur who's just obsessed with performance, you've probably felt this paradox. You've read all the books, you follow the experts on nutrition, but you still feel stuck. Confused, even. Because the rules are always changing. One day, fat is the enemy, the next day, it's carbs. Well, today, we're doing an ambitious deep dive into the work of Mark Carlson, an FDNP, who makes a pretty bold claim. He argues the confusion isn't a data problem, it's that the entire field of nutritional science started by asking the wrong question. So, okay, let's unpack that. For 70 years, the big question has been, what should humans eat?
Right, it's a question rooted in finding the ideal.
Exactly. And Carlson's argument is that this question is fundamentally, unscientific. The better question, the more durable one, is what can humans eat?
And that distinction is everything. It's not just semantics. It completely changes your starting point. Well, the should approach, it leads you down the path of behavioral studies, observational data, and that's exactly why we have these contradictory guidelines and studies that, frankly, nobody really trusts anymore. But the can approach, it forces you to start with fixed physical constraints, things that don't change.
Like what?
The laws of thermodynamics, specific biochemical limits in the human liver, metabolic pathways that are the same in every single person, regardless of their background. So you start with what must be true, what is physically unchangeable, and you reason forward from there. It's about reality, not hypothesis.
Okay. So our mission today is to show you why the standard tools fail so badly, and then introduce this constraint-based method that can replace all that confusion with some real clarity. And to really get why this shift in thinking was so necessary, we have to start with the origin story. Because this didn't come from an academic theory. It came from, desperation. Carlson talks about growing up just steeped in the low-fat dogma. It was treated almost like a moral law, right?
Oh, yeah. That was the era.
We're talking rinsing your ground beef with hot water to get the fat out. Having, I can't believe it's not butter, in the fridge was like a health trophy.
A badge of honor, absolutely.
So he's following all these rules perfectly, and despite that, he hits this massive health crisis. He gets a diagnosis for Crohn's disease, and he does everything he's told. He tries the high-fiber Mediterranean diet, the low FODMAP diet, specific carbohydrate diet, but he does it all within that low-fat framework he was taught was safe.
And it's just not working. In fact, he describes this low point where the expert advice seems to be making him actively worse. He's literally calculating whether he needs to drive himself to the ER.
And that's the pivot. He realized he had to choose between following the guidelines or just trying to survive the next few hours by listening to his body's immediate feedback.
Which led him to eat foods he had been taught his whole life would kill him. High-fat, nutrient-dense foods.
That's the key right there.
What's so fascinating is that the takeaway isn't about one specific diet being the magic bullet. The real lesson was the shift in method. It was forced on him by survival.
What do you mean by method?
The biochemical constraints in his body, how his liver processes fuel, what his gut could actually tolerate, those physical realities. They don't care about expert opinions or dietary trends. They just are.
So his success came from aligning with the hard rules of his own biology.
Exactly. He stopped asking what he should do and started paying attention to what his body could do.
Which sets the stage perfectly. If those physical rules are so unyielding, why are the experts still arguing? Why does nutrition science seem like it's in complete disarray?
This is where we have to look at the machinery of science itself.
Yeah.
I mean, think about it. When physicists measure the speed of light, all the labs, they get the same answer.
They converge on a single truth.
Yes. When a chemist measures the molecular weight of water, it's the same everywhere. The fact that nutritionists constantly contradict each other doesn't mean the human body is more complex than physics. It means their tools are wrong for the job.
So let's get into those tools. What's the foundational problem with how nutritional research is done?
Well, the data sources themselves are structurally, and I'd say fatally flawed.
Okay, so number one, the food frequency questionnaires, or FFQs.
Right. These are the surveys that ask you to remember everything you ate over the last week or month, or sometimes even a year.
And right away, you can see the problem. Human memory is notoriously bad.
It's terrible. And we have studies on this, studies that compare what people say they ate on an FFQ to what they were actually fed in a controlled setting. The errors are staggering.
How bad are we talking?
We're talking about systemic misreporting errors between 20 and 50%.
50%. So half the data is just wrong from the start.
Pretty much. So if you're a practitioner trying to build a protocol on that data,
Yeah.
you're building on sand. The entire data set is invalid before you even start your analysis.
Okay, so that's tool number one. What about the next one? Controlled feeding trials.
Now, these are accurate. You're in a lab. They give you every meal. They measure everything precisely. The data is good.
But there's always a but.
The but is they're incredibly expensive and logistically difficult. So they only last for a few weeks, maybe a month or two at most.
And the diseases we're trying to prevent, heart disease, diabetes, Alzheimer's, they develop over decades.
Exactly. A 6-week trial on cholesterol tells you almost nothing about preventing a disease that takes 30 years to develop.
So you have one tool that's long-term but inaccurate and another that's accurate but short-term. What's the third?
Epidemiological studies. And these are big population studies that get all the headlines. They look at huge groups of people over many years.
Sounds good so far.
But their fundamental limitation is that they can only ever show correlation, never causation.
Ah, the classic confounding variable problem.
That's it. So a study finds people who eat more broccoli live longer. The headline says, broccoli prevents cancer.
But it's not that simple, is it?
Not at all. Because people who eat more broccoli also tend to exercise more, smoke less, be wealthier, see their doctors more often. You can't tell if it was the broccoli or one of the 50 other healthy things they were doing.
You can't isolate the variable, which means, for you, the practitioner, you can't confidently tell a client what actually caused the good outcome.
And then you have to layer on top of all of this the issue of industry funding bias.
Right.
It's not always some grand conspiracy, but the incentive structure is just. It's baked in. The companies that profit from selling, say, breakfast cereal, have a very strong incentive to fund studies that show breakfast cereal is healthy.
And over time, this just trains us all to stop asking what's real and instead ask who said it. Authority replaces verification, and the confusion just keeps going.
It's a cycle.
Okay, so this is where the big shift in method comes in. If that forward reasoning approach, let's test if X causes Y, fails, what do?
You flip the script entirely. You switch to constraint-based reasoning.
Meaning you start with what cannot be otherwise.
Precisely. Instead of guessing what might work, you start with the fundamental laws that absolutely must be true in every single case.
It's a powerful analogy. You've mentioned cosmologists doing this.
Exactly. A cosmologist can't rerun the Big Bang to test a hypothesis. So they start with the laws of physics, gravity, thermodynamics that we know are true.
Yeah.
Then they work backward to figure out what initial conditions are even possible within those laws.
And evolutionary biologists do the same thing.
They can't watch a species evolve for 2 million years. So they start with the constraints, natural selection, genetic drift, and reconstruct the family trees that fit those rules.
So nutrition can do this too. We start with the non-negotiable metabolic reality.
Yes. And we see what diets those realities permit and which ones they completely eliminate. And when you do that, the room for debate just shrinks dramatically.
Okay, so what are these hard, unshifting constraints? What are the facts that can narrow down the possibilities for what humans can eat?
Well, we have to rely on types of evidence that can't lie, can't misremember, and can't be swayed by who's funding the research.
Number one being biochemical limits.
These are hard-coded physical realities. For example, your body has a hard protein ceiling. If you eat too much protein, ammonia builds up and it becomes toxic. That's a fixed limit.
And we also have essential nutrients, right?
We have essential fatty acids and essential amino acids. We call them essential because our body cannot make them. We must get them from food to survive.
Which brings us to the big controversial one. What about carbohydrates?
And this is where basic biochemistry gives us a stunningly clear answer. There is no such thing as an essential carbohydrate.
No, that again.
There is no dietary requirement for a single gram of carbohydrate. The human body has multiple, very efficient pathways, like gluconeogenesis, to create all the glucose it needs from protein and fat.
That one fact seems to undermine about 70 years of nutritional advice.
It completely reframes the foundation. It shifts the starting assumption from we need carbs to we can run perfectly well, maybe even better, without them.
Okay, constraint two, historical evidence.
This is where it gets really cool. Your bones preserve something called isotopic signatures. Basically, the ratios of different carbon and nitrogen isotopes in your bone collagen tell a story.
A story about what you ate.
Exactly. They reveal your trophic level, where you sat on the food chain. And these signatures can be read thousands of years later. They can't be misremembered. They are a physical record of what a population could and did eat.
And third, the metabolic mechanisms. Understanding the machine itself. You mentioned the Randle cycle.
Yes, the Randle cycle is crucial for understanding modern disease. Can I break it down quickly?
Please do. What is it, and why does mixing fat and carbs create metabolic confusion?
So, simply put, the Randle cycle describes a competition inside your cells. The cell can burn either glucose from carbs or fatty acids from fat for fuel. When there's a lot of one, it blocks the burning of the other.
It's an either-or system.
It's designed to be. The problem with a modern, I think, pizza, ice cream, donuts, is you're flooding the system with high amounts of fat and high amounts of refined carbs at the same time.
So the system gets overwhelmed.
It creates a kind of metabolic traffic jam. Neither fuel can be burned efficiently. This leads to energy being stored as fat insulin resistance, a state that really has no precedent in human evolution.
Okay, so we have biochemistry, we have history, we have the cell's mechanics.
And then finally, you add the last layer, individual verification. This is where we acknowledge that, yes, genetic variation exists. Some people handle starch better. Some can digest lactose. The big constraints narrow the field of play. And then personal calibration finds your sweet spot within those boundaries.
So when you layer all those sources together, the biochemistry, the bone isotopes, the metabolic pathways, and then individual genetics, the contradictions they dissolve.
They do. The constraints eliminate all the impossible options that the old should question left on the table for everyone to argue about forever.
And that really is the core of it, the difference between asking what you should eat, which just creates arguments, and asking what humans can tolerate, which leads you to undeniable physical realities.
And when you stop asking should, and you really start examining what the hard evidence shows, what our metabolic machinery can actually sustain without breaking down, the conclusions you come to are often really surprising to people. It forces you to rethink what a healthy diet even is.
And we are going to get into those stunning conclusions next time. We're moving from the how to the what. We'll read those constraints and look at the specific isotopic evidence from bones that cannot lie and see what our ancestors were actually eating. Thank you so much for joining us for this deep dive. If you want to go deeper into the first principles thinking we talked about today, you can find Mark Carlson's essays at healthundercontrol.com.
And for services and resources that put these principles into practice for you or your clients, you can visit unblocked.health.
We'll catch you next time as we continue unpacking what you can eat.